with the recent release of Surfsense, I decided I'd take the opportunity and, since it's open source, go ahead and integrate Dionysus, which is my consciousness system, into Surfsense using Surfsense as the information gathering and research front end. So actually, you can see the architecture right here. Surfsense on the front end serves for the UI, documentation, and interaction. Surfsense on the back end, enhanced consciousness, which I break down here. Memory formation happens through episodic document processing experiences, semantic extracted content relationships, procedural, the algorithmic pattern. What happens there is any algorithms or patterns. I mean, it's kind of self-evident, but I just want to clarify anyway. Any algorithms or patterns that the system reads in a paper, it will do its best to turn that into an executable piece of code. The benefit of that is it accelerates integrating any papers I come across or that you come across in the system into the larger consciousness simulation. It will also tell you what the benefits would be so that you don't end up with duplicate, triplicate code. And in some cases, um, one of the benefits of the executable code itself is that it will decide during the procedural memory creation whether or not it would benefit from the code that it's going to create and how that would impact the system overall if you were to run it. I'm not 100% sure if I'm not 100% sure how I have it integrating, whether it's a choice or not. I think that should very well be something where there's a library of the accumulated simulation code and you can check off some. That probably will be useful later. So, attractor Bayesian processing. This came from the context engineering class by David. What's David's name? Hold on, this is worth checking out. So the context engineering class here by David Kimai provides an attractor-based mechanism for integrating incoming information. It passes through, the way I have it implemented is it passes through, when information comes into my perceptual gateway, which is the only way into this system that I have wrapped in a Markov blanket simulation, when it passes through the perceptual system, it gets um, it gets delegated to a system I have called. Sorry, y'all, it's early. A system I have on here called Datalist. Datalist is in metaphor to the labyrinth, and essentially Datalist is like a supervising agent. It's using LangChain, LangGraph for this part. It generates an agent within a container, and at the same time, the information passed to the agent. Um, but let me run that back. At the same time, the information passes across a attractor basin, basically representing the different concepts. Based on what concepts were recently activated, you'll have, I think there's four basins. Each one represents a semantic well, basically. It has a gravitational pull, and based on the similarity and relevance of the terms coming in, they may or may not get sucked into one of those basins. If the basins that were most relevant don't match it, then then the result is that it creates a new concept basin. Now, after they've passed through the basin, there are other memory systems. There's a working memory system which maps relatively closely to the basin. There's a thought seed implementation, and I'm surprised it's not on here, but the thought seed implementation is we'll have to pull it up later. The thought seed implementation is from it's an inner screen concept of conscious emergence, and it's tied to global neuronal workspace theory. which is an extension of Bernard Barr's global, well, yeah, global workspace theory. Okay, so global neuronal actually talks about how it works. I digress. So, in addition to that, so there's cognitive architecture in the. This might worth doing in this system in the context engineering infrastructure. There is there's a set of cognitive tools and out of IBM apparently. So here they are right here. I won't read them to you. Understand as I start reading them to you. They say what they do. These are different cognitive tool templates that exist. I think this system uses a biological metaphor, so atom, molecule, cell, organ, and so on. And organ is multiple agents, I think, and cell is a single agent in that metaphor. So this, these, well, schema. Well, these are tools to allow you to, without too much complication, run these different methods. Methods is object oriented, but run methods. Some of these are pretty cool. It also has cognitive architectures and cognitive schemas. And I haven't messed with these or read these yet, but it also has integration ways to. Yeah, I haven't read all of them yet, but it looks like RAG and other systems. An explanation and a quick start. So back to this. So I've already explained this. So like my main place of enhancement is within this basin right here. That's where I've been kind of messing with the code the most. So enhanced RAG capabilities. What I've done here is I created a hybrid memory system. You have your traditional vector set. Well, the information passes through working memory, episodic memory, which is like narrative form, semantic memory, which is sort of a generalization of the individual autobiographical experiences, to general form, like concepts. And then there's also the procedural memory, which I discussed here as executable code. I'm repeating that just because this is what I do in the morning. You just happen to be here for it. So code generation, I already mentioned that. This kind of elaborates on how it does it. There's a Datalist I mentioned is the Labyrinth guy, architect of the Labyrinth. So I use Datalist as the main delegate, creating different agents. It's creating the agents into Docker containers. I found a container use tutorial, and I have to link to it, but I found a container use tutorial that is integrated in here. So instructions, benefits. Okay, so beyond the traditional RAG, the benefits the system has is memories persist across sessions. It's basically a lifelong relationship with the system, including personality aspects, but we can talk about that another time. Conscious processing, I mentioned that. Attractor basins, code generation, code becomes executable. So I have research discovery. I've put a curiosity algorithm in here. In addition to R0, R0 was a system that it rehearses. It's a challenge system. It asks itself questions, and if it and grades and pass fail based on degree of confidence in the answer, correctness of the answer. What I did is I rigged in here a system where the once it gets wrong, it uses that research system you saw above, and it goes on this. Basically, it creates cognitive dissonance. It triggers memory reconsolidation, a simulation of that, which is when you have an error, a prediction error in active inference, which is like a Bayesian predictive processing. It's a model of brain. So when there's an error, when there's a belief is contradicted, the entire relevant part of the system, the schema, becomes labile, and it's malleable for about a 5-hour period. I think in this implementation it's only a 30-minute period. So it's open to being this is Piaget, assimilation and accommodation. It's open to becoming a different schema. Coherence therapy works on this. So basically, a lot of this is basically coherence therapy encodified. So there's the concept of the juxtaposition, where the memory gets compared against the new memory. It finds the differences and it basically either updates the old memory if it's not that big a difference, or it replaces the old memory. There's a sub process in there going on, representational redescription. You could find that in the theories of like some of the learning theories under constructivism. I can't remember the lady's name, but if you look up representational redescription, it's not like a general conversational term, so you'll find like a lot of the teaching literature on it. Beyond that, in active inference, you could think of it as bringing something to consciousness. Once you bring it to a certain level of consciousness, you're able to actually move it from procedural memory to a more declarative memory, like one you have words to. And what that lets you do is to break the process down into steps and correct some of the steps. It's almost like you think of it as bringing attention to something and making it what they call phenomenologically, might have an extra syllable in there, phenomenally opaque, so you can see it, versus phenomenal transparency, which you're in it, so you can't see it. It's like a third person shooter versus a first person. So opaque means you can see it, and once you can see it, you can um, adjust it. You can make changes to it without, well, you can make changes to it. Right now, I have it set on let's see, research discovery. I mentioned that that's a curiosity aspect. Uh, my graph system, it extracts information from any of the studies, and it passes it through the hybrid memory system. So it passes it to the vector based one for finding the semantic space, and then it also, that ID in the semantic space in the vector database gets mapped to the graph database. So it's sort of a hybrid retrieval. The graph database allows all relationships. It looks for relationships with other concepts that already exist within the system. So I figured, like, what is it? Obsidian has a double direction linking. The goal was, and I still have to check on the implementation, to have it that when a concept comes in, the other concepts that are relevant become aware of it. This is basically analogous. It's the graph database analog to when you see the attractor basins earlier do the semantic similarity, the really the relevance retrieval in the attractor basins when it first comes in. So that's concept mapping. Local first, what I've done is I've got DeepSeek running in a Llama, and I also have Facebook's mid-size engine. I think that's Llama, because this all the churning and rehearsing and all that stuff. If it's doing it on a remote server, if it's doing it through an API, it's gonna cost for real. Um, so yeah, so I guess we have enhanced RAG. Not discussed here is there's multiple layers of learning, self improvement happening, where uh, we implemented prompt learning. There's a study I came across that showed that prompt learning was more effective than, well, it took way less data, happened in real time, uh, interactions with the system. So as I'm talking to the system and concepts are coming up and I'm complaining, it's learning to understand my prompts better. There are a couple other implementations of prompt learning that aren't coming to mind right now. Hold on, it's going to generate code. It's cooking. Um, I'm looking to see if I can find that for y'all. Prompt learning. Maybe not. Okay, so prompt learning. Where's my docs? I have some docs. Prompt learning, as I mentioned, It's I think it's 1/10. They say it's supposed to be like reinforcement learning on steroids, because it takes a fraction of the data. It happens in real time. It happens around the conversation. I think Marcel Mintz, is that his name? Marcel Bintz, B-I-Z. He does. He's the one that came out with the Centaur engine. He does a lot of work around customizing open source LLMs for mental, like psychology, mental work. He has a database called Psych 101, which he which has 160, I think, psych tests, and he found that he could train Llama to outpredict thought processes, outpredict other systems like other open source engines on predicting human thought. So it came out. There was a little bit hype around it for a little bit. He also, the reason I'm bringing it up is his concept of in context learning. This is a lot of what I'm doing here is my attempt at creating that. So I thought it would be kind of pointless to have a system that can do that in context learning and not have my entire architecture do that. So there's also an episodic episodic meta learning going on. Meta learning is learning to learn. So the system, as it's accumulating interactions, it becomes better at various steps along the pipelines. Have it implemented for the meta learning across all memory systems, across the procedures, which ultimately means the code is gets better that way. So, oh, good, good, good. It added the Google authentication. Um, so Surfsense. I wish I had more on here. I was hoping it would pop up. Surfsense is Surfsense is an open source version of Perplexity and Notebook LM that just got released or just came across my timeline 2 days ago, three possibly. And I was like, why reinvent the wheel? So I grabbed it because it's also connected to the web search and some other stuff, some other um, content retrieval systems. And so while having the documents in here, I figured I might as well allow all the documents across different notebooks to have access to that one central reasonable graph system. What that will allow is when you're in a topic, you'll be able to pull up um, relevant topics from the larger personal collection, like your collection of documents. I haven't dug in to check out the Perplexity feature, which should allow for basically creating, uh, retrieving stuff, putting it in the database, and then creating explanations of that. And clearly, this is long enough already, so I just wanted to kind of step through that because I will probably be implementing instead of writing up docs, and I thought that might be useful for a few of y'all kind of working through. Um, Probably on your local version, if you go hacking, you want to uh, not use my email as yours.